Okay, Isaac. This is what I was doing wrong when you were in here, and I had to sit down and actually think about it. A red blood cell is a sphere. Okay. So when we're calculating the surface area and volume, we need to be doing that for a sphere. And I was thinking cube. So we did need the formula sheet. And on the formula sheet, it gives the formula for the volume of a sphere and the surface area of a sphere. So we have the surface area being 4 pi r squared and the volume being 4/3 pi r cubed. And we know the diameter is 2r and not r squared, it's 2r, right? So that means the first thing we need to do, so it gave us the surface area and volume for a normal red blood cell, and we can calculate the surface area to volume ratio with that. And we know that the surface area to volume ratio, which is SA over V, is just 136 divided by 91. So that gives us a surface area to volume ratio of 1.494, okay? That's our surface area to volume ratio. Now, the first thing we need to do to figure out which one is more efficient is figure out the surface area to volume ratio for someone with that disorder. So we need to figure out what R is, and so in order to figure out what R value is, we take this 6.7 and divide it by 2 to give us R, and then of course 6.7 divided by 2 is going to be 3.35. Now we just plug in the values. So when we do 4 pi 3.35 squared, so I'm going to put that in a calculator. 4 pi 3.35 squared. That's going to give me 141 micrometers squared. And then we'll do the same thing for volume. I'm going to do 4/3 pi 3.35 cubed. And so, let's see, 4/3 pi 3.35 cubed. That gives me 157 micrometers cubed. So then I do the same thing, surface area to volume ratio. So I'm going to take 141, divide that by 157, and that's going to give me a surface area to volume ratio of 0.898. And so we know that if the surface area to volume ratio is smaller, that means the cell is less efficient. All right. Sorry I couldn't do it while you was in here, but I had to actually think about it. And then once I realized I wasn't doing a cube, I was doing a sphere, then it made more sense.